Okay, good afternoon, Year 8. We're carrying on with our topic on waves and electricity. In particular, we are looking at light waves in this session, and we're going to be looking at reflection and refraction, okay, and what they are and their differences. So by the end of this, you're going to be able to describe the rule for reflection, and you're going to be able to explain what refraction is and how it occurs. So, I would like you, please, to just have a think and see if you can come up with your own definition for what reflection is. Now, pause the video here and just write a sentence maybe about what you believe reflection is. Okay, so hopefully you've done that. And this is what I came up with. Now, reflection is when light hits the surface of an object and bounces back to our eyes so we can see it. Now, when light from an object is reflected by another surface, it changes its direction. Okay, and the angle that it hits that surface at is exactly the same as the angle it bounces off at. So, smooth, shiny surfaces such as polished metal, mirrors are really, really good at reflecting light. But dull, dark surfaces such as black fabric, browns, wool, rough surfaces aren't very good at reflecting the light because it does not bounce back in the same direction. So if we look at this diagram here, you will notice this green line. Okay, this shows a light ray, and you will notice on this line there are some arrowheads, and this shows the direction of travel of the light. Now, as I was saying a minute ago, the ray of incidence, which is the light coming in, bounces off of the surface at exactly the same angle. Now, the angle that the incident ray hits at is called the angle of incidence, and funnily enough, the angle it reflects off at is called the angle of reflection. Now, you will note on this diagram that light is shown as a straight line. You've got the arrowheads, as I said, pointing direction of travel. You've got this line here with a hatched vertical line. This represents a mirror, and we've also got this dotted line here, which is called the normal, and this is always 90 degrees to the surface of the mirror in this case, or the surface that the light is bouncing off at, and this is what the angle of incidence and the angle of the reflection is measured against. It's really important that you remember that, guys. It is the interior angles here up to the normal, not going down to the mirror. So, the law of reflection states that the angle of incidence is equal to the angle of reflection. So, if the angle of incidence is 30 degrees, angle of reflection is 30. If the angle of reflection is 90 degrees, then the angle of incidence will also have to be 90. 30, 40, 50, 17, whatever, they will be the same. Now, if a light ray traveling along the normal hits the mirror, so if it was coming straight in perpendicular at 90 degrees to the mirror, as this diagram shows, so the light would come in like this, how would it reflect back? Yeah, it would bounce back and go straight back to where it had come from. So, the reflection of light from a flat surface in this instance, such as a mirror, is called specular reflection. And this basically just means that all of the light is reflected back in the direction that it came from, in one direction. It isn't spread out at all. Okay, now if you look at this diagram, it's a ray diagram, but what do you notice? We've got an uneven surface. We've got our light rays coming in. But look at how they're being reflected off. They're all going off in different directions. Now this is called scattering. Okay, as you can see there, I'm not going to read it out to you. I'm not going to say it. It's just a rough surface, reflects the light back in all different directions. Okay, now this is diffuse scattering, and it's why you can see a clear image of yourself in a shiny surface such as a mirror or a polished metal, but not on a dull, rough wall. Now, refraction. Again, what I would like you to do, I've given you a bit of a clue there with that diagram. Okay, what is it? See if you can come up with a definition of what refraction actually is. Okay, pause the video, give yourself a couple of minutes just to write down a sentence or two about it. Okay, now hopefully you've done that. Refraction, okay, is the name that we give it when light waves change speed when they cross the boundary between two substances with a different density. So if you put a pen into a glass, fill it with water, you will see that the pen appears to be disjointed and moves. This is because water is denser than air and it causes the light rays to change speed, creating the illusion that the pen has bent, and as I say, it's known as refraction. Now, as I say, as light hits the water is denser than air, so it slows it down, and the ray bends in towards the normal. If you remember, that is 90 degrees from the surface of the changing substance. Okay, as it exits the more dense substance, it then bends away from the normal, returning to its original direction of travel. Now, an example that you've probably seen in school is this one, where we shine a ray of light through a glass block. So you can see light's traveling through the air here, hits the surface, glass is denser than air, causes the light to slow, bends away from normal. Okay, it then emerges from the glass block, can speed up again, and returns back to its original direction. Now, I'm just going to show you a video, which I think you'll enjoy. Okay, this is just a bit of fun. Now, just quickly, that video was talking about light being absorbed. Now, if you noticed in that video, they were actually different colours. Why do you think we see colours? Okay, now colour is visible to us as humans because it is what is reflected back off of the surfaces around us. So, if you look at the wall behind me, you can't really see it in this light, but it's sort of a greeny white, an apple white, or a spearmint white, you call it. And this means that the colours that are reflected from that wall are green and white. Blues, reds, blacks, browns, whatever, are actually absorbed, so they are not reflected. So our lights do not, our eyes don't see the light so we cannot see those colours. Now, one last video, and then I will set you off on your task. Okay, guys, so your task, which is now on Shobi, is I would like you, in your own words, to explain why we're able to see a reflection in a smooth surface and why we cannot see a reflection in a rough, uneven surface, and also explain what causes refraction and how it works or why it happens. Okay, now I'd like you to use some scientific terminology in your explanations, and I expect at least a paragraph on each. Okay, it is a 6-mark assignment, so you want to be looking at giving at least 3 points for each. Okay, well, best of luck and have fun.